this is Mr. Max with my fifth problem on the applications of differentiation. So it says the diagram shows an open container, and this container is constructed out of 200 cubic centimeters or square centimeters of cardboard. The vertical end pieces are isosceles triangles with sides 5x, 5x, and 8x centimeters respectively. The two sides are rectangles and they are y meters long and they have a width of 5x. We're supposed to show that y equals to 200 minus 24x squared upon 10x. Okay, so there are many ways you can do this, right? So first of all, if you look at this particular triangle here, and I'm going to draw a rough one here. So it's isosceles triangle. And the reason why I'm looking at this triangle, so this is 5x, for example. If I was to drop a perpendicular, okay, so that's going to cut it into 4x, for example. Okay, so, and this is going to be the height. So if I want to find the height, I will use Pythagoras Theorem. And Pythagoras Theorem will say h squared equals to 5x squared minus 4x squared. That's what Pythagoras Theorem gives me. Okay, just make sure 4x squared. Well, so h squared gives you 25x squared minus 16x squared. All right, so this gives you h squared equals to 9x squared. Therefore, x equals to square root of 9x squared. And everybody should know that the square root of 9x squared is nothing but 3x. So if the height, therefore, if the height is equal to 3x, and we can actually now find the area of these two triangles. The reason why I'm doing that is because I want to find the area of everything and let it equal to 200. Okay, so we also know that you can find the area of the rectangle, which is this here, one here, plus the other one which is going down there. Okay, another one inside, all going down there. So I'm going to add all those areas, okay, and I'm going to be able to equate them to 200, and then I make y the subject of the formula. Okay, so the area of two rectangles, so the area of two rectangles, it's a half times the base, and the base you can see is 8x. Okay, the base is 8x. All right, the base will be 8x. So let's see. And the height we already determined is 3x. So there will be two of them plus two of these rectangles, and these rectangles have 5xy, 5x times y, so 2 times 5xy. So I'm going to let everything later on equal to so 8x, that is going to be 24x squared plus 10xy, so everything should equal to 200. Okay, so from here we are going to make y the subject of the formula, so it's going to be 10xy equals to 200 minus 24x squared, and we'll go ahead then and divide everything by 10x, so y will be 200 minus 24x squared, and we divide that by 10x. So just to make sure, what is it that we need to get? Well, we've got to prove our exact value. Okay, 200 minus 24x squared upon x. So we have now the value of y. So now that we have the value of y, okay, we can do quite a number of things. Right, so they are saying we are supposed to show that the volume is equal to this value here. So the volume we find by the area of that triangle. So if you had to calculate the volume, it will be the area of the triangle multiplied by y. Y is this length here. Okay, does that make sense? So we already determined what the area of one triangle would be. We know that height of the triangle was 3x from our previous work. So the area will be a half times the base, which is 8x, times the height, which was 3x, times y, okay, in order to find the volume. Right. We also know from my previous work that y equals to 200 over 200 minus 24x squared over 10. Okay, so volume then, to have my volume then, it will be a half 8x times 3x times, we have 24, just make sure we get it correct, 200 minus 24x squared, it's 200 minus 24x squared all over 10x. Okay, right, so when you have 8 times 3 is 24, half of 24, this gives you 12x squared, and then we're going to multiply that by 200 minus 24x squared over 10x. Well, from here it's just a matter of playing around with your algebra. So before the 12x squared, this is going to be 20 minus 2.4x, okay, because I'm dividing here by 10, okay, and obviously if I do that, I put everything over x, just to make sure we are on the right path. Okay, so 10, basically, if you know, I cut, well, 10 goes there, deliver 20, and then obviously get to 2.4. All right, so now we can actually cancel. So it's going to be 12x, and then we have got 20 minus 2.4x squared. Okay, so we can actually go ahead and we can find the volume. So 12 times 12 times, so that's 240x minus, well, you can grab a calculator if you're a little bit unsure about this one, 2.4 times 12, well, that gives you 28.8, so that is 28.8 x cubed. Right, so that is the volume, and that is what we were required to prove, 240x minus 28.8 x cubed. Okay, so now we have the volume of the container. All right, so the next part, they say given that x can vary, find the value of x for which v here is a stationary value. So basically what that means is dv dx should equal to 0, and we know from our previous work that it is 240x minus 28.8 x cubed. Just make sure that we have written it correctly, 240x minus 28.8 x cubed. All right, so we can actually differentiate this. So dv dx is equal to 240 minus, so you take your calculator out, you say 28.8, multiply that by 3, well, that gives you 86.4, so it's 86.4 x squared. Obviously that should equal to 0. All right, so we have to first find the value of x. Okay, so what is going to be the value of x? So minus 86.4 x squared equals to minus 240. So x squared equals to minus 240 divided by minus 86.4. Okay, so x will be the square root of that. So 240 divided by 86.4, 25 over 9. So 25 over 9, and the square root of 25 over 9 is nothing but, oops, let me just correct that, not 29 over 5, but 25 over 9, which is nothing but 5 over 3. So now we have the value of x. The value of x is 5 over 3. Okay. Then they say determine whether this value is a maximum value or a minimum value. Okay, so we already know that dv dx is equal to 240 minus 86.4 x squared. So if we do the second derivative, d square v over dx squared equals to, well, that's just going to be, let's grab that in, 2 times 86.4, just make sure it's 172.8, so it's negative 172.8 x. So if x is equal to 5 over 3, so let's see what that value would be. And well, that value is going to be negative. So it's negative 172.8 multiplied by 5 over 3, and with 5 over 3 turns as minus 288. And this value here is less than 0. Okay, therefore, to determine whether it's a maximum or a minimum value, it is a maximum value. Okay, maximum area. Okay, so you just make sure that you do get step by step to find the processes, and then you are ready to go. You need to know when you're supposed to differentiate, when you're supposed to take the second derivative, especially when you need to determine. Let me just correct that one. Okay, so the line doesn't look so weird. When you need to determine whether something is a maximum or a minimum, that is where we take our second derivative. And if that value is less than 0, we are now talking about a maximum, right? Maximum value, maximum volume. All right, so it's a question that has been divided into quite a few parts, and you need to be able to remember a few of the things like Pythagoras' theory and find a height, write that height in terms of x, and from there on, continue with the rest of the question.